So every day for lunch, my wife, as you get older, sometimes you need to take some extra supplementation for regularity and things like that. So her beverage at lunch is Miralax, which is water with it's like a stool softener thingy or whatever. But that's what she drinks. That's not a drink, right? You don't drink that. I mean, you drink it, but it's not your beverage. That's like medicine, right? Yeah, that's a sipping drink for her. Oh, I haven't even thought about that. I like where this conversation is going, because I usually drink a pot of coffee at 5 in the morning. I sit there and I stretch and I play Hearthstone. But now I can drink my coffee and other supplementation.
Yeah, I've tried Miralax and
All right, so we've covered our laxatives and different ways of consuming coffee. So why don't we go into insertion sort now? Turkey bacon flavored water. Oh, you mean Dasani?
No,
No. He was complaining he doesn't drink Dasani water.
Oh yeah.
Because it's turkey bacon flavored.
The worst part about Dasani water is that the bottles are so nice.
Jonathan goes,
the water is...
It's a laxative. That's worse than daily Taco Bell.
No, I'll run a business someday that's turkey bacon flavored water.
Well, you'll go out of business.
Aquafina is the water of choice.
Isn't Aquafina Pepsi and Dasani's Coke? And then, so those two things are just the water, the purified water they use in their soda products.
Huh, really?
Yeah, they just say, hey, we'll put syrup in it. We'll still charge you for it.
We'll just sell you water.
All right, am I sharing my screen?
Probably.
Yes, I am. All right. Do we have it inside of my functions? Oh, it was in link list. Insertion sort link list. We need to do our swap. This guy?
Yeah.
Okay. So let's just catch up mentally here for how insertion sort works. Remember, we start at bucket 1, we keep, and then we have something called like the follower that goes back from there. So we start at bucket 1, we say, should this guy come before the guy before me? If yes, we do the swap, but we don't ask, should it come before me if I'm at bucket 0? So once we get to bucket 0, there's nobody to compare before me. So we start at bucket 1, we go to bucket 2, bucket 3, and then we take that element and move it towards the top of the list as far as we can go. All right, so we have our list starting at bucket 1, curse start. Keep going as long as it's less than the number of elements in our linked list. Each time through increment curse start, we reset the value of the follower pos. Then we go ahead and grab the follower node. This is the actual node that lives at the follower pos. All right. Then we ask the question, if the follower pos is greater than 0, that means we haven't already gotten to the front of the list, and the payload in the follower node should come before the payload in the follower pos -1's node. That means I should do a swap. All right. So if that's what this if statement, this while loop says, while I should do a swap, let's do the swap. So what does it mean to swap here? Well, I'm going to need a temporary node to hold the guy. I think for this assignment, I remember specifying you couldn't just swap the payloads, right? You actually had to do the surgery. Okay, got it. So what we want to do is we draw a picture here. Let me see here. We actually can do this with, I'm gonna hook up the wires. It sounds like it's more fun. Just steal this slide. Ninja. All right, so this is going to be follower. This is going to be cur start. Let me just order these a little bit. All right, say something like that. All right, so if I'm currently at, let's just use this as an example for cur start. If I'm at cur start and I should swap with the guy before me, that means what I need to do is I need to make this guy point to this guy. So I need to perform this surgery. So I need these two guys to switch places. So I need to get a pointer to this guy, which I have, right? So I'm going to go ahead and give myself, I have a pointer to this guy. This guy is called the follower. I need to go ahead and get a pointer to the guy before him. So let's go ahead and grab that. So we have our swap node. So we'll go ahead and say swap node is equal to this get node at index. This guy right there. All right. So now we have access to a variable called swap node. All right. So we want to set swap nodes next node to be here. Then we want to set the followers. Well, these are all the steps we want to do. We got to decide what's the order we're going to do these in. So ultimately we want swap nodes next node to be here, which is the followers next node. We want the followers next node to be equal to swap node. But then we need the guy before swap node to point here to hook them back up. All right. So we're going to need to go ahead and get up to the point that is the guy before swap node in order to pull this off. So let's say we have a node pointer before swap node. And we'll go ahead and say swap node, whatever, before swap node, right? Before swap node is equal to this head, while before swap node get next node is not equal to swap node. I need to set swap node before that. So while I'm not at the node immediately before swap node, I'll say before swap node is equal to before swap node get next node. Set him equal to his own next node. So that'll take our before swap node. And we'll start it off pointing to the same place head points to. And we'll say as long as we are, while before swap node's next node is not swap node, where in this case it is. So we won't move him down the list. But if it wasn't, we would set him equal to his own next node, jog him down the list. So right now, before swap node points there, swap node points here, and the follower points here. All right, so if the thing we want to be careful of is don't let pointers float out into space. Okay, so now I have something pointing at all of my things that are involved in this surgery, right? All right, so now it really doesn't matter the order in which I perform the instructions. So ultimately, I'm going to want before swap node, well, actually, I like doing it this way. We're going to make swap node point to the same place that the follower points to. So we're going to say swap node, set next node to the follower node. Do we not have a get set node? Get? No, I would have called it get. Oh, thank you. When I typed it, I thought the node one was the top one. The follower node. It was, it just wasn't the one selected. Get next node. So we'll set swap node's next node to the same thing as the follower's next node. So that's this ninja move right here. Swap node's next node is equal to the follower's next node. They both point here. Then we want to set the follower next node to be swap node. The follower node set next node to swap node. So that's this ninja move. The follower set next node equal to swap node. And then finally, before swap node, set next node to the follower node. Like that. So now we have swapped those two things. So now before now goes here, which then points here, which then points here. All right. We need to make sure now, as of right now, the follower node is what this guy's called, right? That guy still points at the right place, just his position has changed to be one less than it used to be. So we need to decrement the follower pause minus, I think is what it was called. The follower pause minus. Because even though the node itself has not changed, his position in the list has changed. Make sense? All right, so I think that should cut it. I just want to do, you have a question, are you wanting to talk about a special case for bucket one? Okay, that's what I'm about to talk about. Yep, but that's what you were gonna ask, right? Okay. So let's now play, I'm gonna set this to a 4, and we're going to set this to a 2 is fine. All right. So this is the follower node. Just disconnect these guys here for a few minutes. All right. So let's see. This goes here. This goes here. This goes here. That's fine. So if I'm currently right here, and I say, should the 2 come before a 4? Well, first of all, I am not at bucket 0. Okay, but I'm close to bucket 0. Okay, so I'm not at bucket 0. So should this 2 come before 4? Yes, it should. So I need to do my swap. So what do? Well, we set swap node equal to this guy. So we're good with that. All right, but now we need to set our before swap node because we want these 2 guys to swap, right? But our before swap node should go to something that came before this guy so we can set it up. But if swap node is equal to head, if these guys are the same things, that means there is nothing before swap node. So if swap node is equal to head, we want to do something a little different. What are we going to do? If swap node is equal to head, we're going to set swap nodes. Yeah, this will work. We're going to set swap nodes next node equal to the follower node's next node. And then we'll set head. Well, actually, then we'll set the follower's next node equal to swap node. So those two steps always happen, right? But then we set head equal to this guy. All right, so we need to write our logic for that. So we're going to ask a question right here. If this head is equivalent to swap node, if they're the same things, then we want to do these two things. And then ultimately set this head equal to the follower node. Else, we'll do all this stuff. In either case, the follower follows. What's up?
Mine was so complex.
I don't think we need to do anything special for tail, do we?
You just need to, unless you want head and say the wrong thing, I think you need to set tail.
Oh, yeah.
You don't need to do anything special.
Right. So we do need to ask the question now if, let's see, before we decrement follower pause, we would say if the follower pause is equal to this, does it get this count minus 1? Then we'll say this tail is equal to swap node, because that's the new tail, right? So this guy resets tail if we are swapping away from tail.
Do you have anything, the node that you're swapping, do you have anything point to whatever that is swapping? Is that doesn't make any sense. Do you have anything
Well-
point to whatever swap node is pointing to?
Well, yeah, swap node's next node.
Okay, so if you were swapping the tail, then we need to want to need to, or you would at least need to not set anything to.
Well, here, well, let's do the tail example here. Let's just make sure we're good on this example. So this example says, if I'm the guy right before this, then I'm going to, let's see, let's just reset it here. Head points here. So if we want to, we have our swap node, that guy's going to get set the right way. It's going to be the guy right before that. That always gets set the same way for swap node. Then we're going to say if swap node is equal to head, we're going to do one thing. And what's that thing? We're going to set swap nodes next node is equal to this. And then, so swap node's next node is equal to the follower's next node. Let's make sure we've said that. Yep. Then we're going to set the follower's next node equal to head. That guy. And then we'll set head to be the follower node. So that's our special case on the front of the list. For the end of the list, I think we already tested the middle part. For the end of the list, if this is the guy we're swapping with the dude before him, come on. This is my follower node. So something like that. All right, and curse start points there too, but that doesn't really matter in our algorithm here. So we say, are we at the front of the list? No. Should a 1 come before a 2? Yes. So what do we need to do? We're going to set swap node equal to the dude right before him. So swap node is equal to this. Then we can go ahead and get the guy before swap node, which will be that same logic, right? There's the guy before swap node. Okay, so we have that piece. Now what do? Now we're going to go ahead and we're going to say before swap node, set next node to here. I don't remember which one I like doing first. Let's just follow our current instructions. I said swap nodes next node first. So I said swap node, set next node here. Then follower, set next node to swap node. Like that. And then before node, before swap node, set next node to follower node. This guy's set next node. Oh, sorry. Before, let me set this back up because this is my swap node. I was treating this as swap node before. Let me just follow those instructions again. Swap node, set next node to the follower node. So this guy is swap node. So we're going to set his next node. We're pointing at this guy. This guy should come before this guy. So I've set swap node equal to this guy, and let's just move this down there. That'll be easier to keep track of with all our zigs and zags. Follower node is this guy over here. All right, so we ultimately want the before swap node to point to our follower node, and our follower node should point to the guy before him. So we want to set this guy's next node. So the follower node, let's go through this. So swap node's next node points to the follower node's next node. Good. So swap node's next node, this guy here, points to the same place that the follower's next node points to, which is nowhere. That's null. That's correct. Then the follower's node, set next node, points to swap node. Follower's node, next node, points to swap node. Then before swap node, set next node to the follower node. Before swap node, set next node to the follower node. All right, then we ask the question, if tail currently points at the follower node, so actually what we can do is we can ask the question this way. If this tail is equal to the follower node, we could have done it with pause for the -1. Actually, what we had there before was accurate because we didn't subtract until after that. but this is more of a better pointer question maybe. So we're asking the question, if the tail points to the follower node, which right now tail points at the follower node, which is no longer the tail. We now need tail to equal swap node. Tail is equal to swap node. No matter what, if we did a swap, the follower follows.
Could you also ask the question if tail points to, or no, if tail, never mind, I forgot.
I think you're thinking if tail and head are the same thing.
No, I'm thinking if, basically like if tail is not correct, like if the tail is pointing to something else, that tail too won't point.
But how do you ask whether it's correct?
If the current tail is pointing to something, like if tail gets messed node is not node.
Okay, but the idea would be as long as we've inserted things correctly, tail should always be pointing to the end, right? Head and tail always point to real things if we wrote our insert and all that jazz correctly. All right, so I think this should do it. So this will just keep doing the swaps. Each time through when we do a swap, the follower pause will say minus minus. So eventually we fall out of this while loop either when we finally get to a 0 here, or we're not supposed to swap. And we've done our surgery for hooking stuff up or whatever. Am I calling this yet from my driver? So there's me filling my array. But no, this is an array. We should be filling a linked list, right? We wrote insertion sort in class for arrays, and now we're supposed, okay, got it. Get my linked list in here. So I'll go ahead and dump this array. Instead, we'll say a linked list, LL is equal to a linked list pointer, right? This is C++ equals to a new linked list. So we have our empty linked list now. We'll go ahead and get our random number, yada, yada, yada. And we'll say LL add end val. So that should fill it up. Does our linked list have a display? It seems like it probably should. Ninja. Then we'll call our linked list insertion sort, LL insertion sort, and then tell our linked list. Here, let's just do this real quick. Let me just display our filled linked list first, and then I'll uncomment that or comment that and uncomment the other two to show our sorted version of that. And where am I here? What class is this? 300? Very aggressive with my term. It's anger management, right? Okay, so I could. What's this? Terminal. What'd I do? All right, so there's my randomized linked list thingy-majig. Oh, actually, it would have looked good if I forgot how my linked list printed out. So we're going to show them both. So then we'll call insertion sort, and we'll display it again. File it again. Good.
Did you add another line where it's just a two that turns out or that says what the
Payload of the tail, okay?
that was one of the things that wasn't required. for me, there was one thing that
We using printf or cout? What are we using? Cout. Am I going to be able to get at the tail directly? I don't think so. Isn't tail private? Ah, here, we'll just do this. We can fix this real quick. Well, here, we'll fix it even quicker. Nothing to see here. Now we have access to tail. Get payload. Is that how you do cout? I think so. So it should be, well, we'll have to see what it's going to end up being in this. 973?
Yep. Awesome.
I should get one of those straws for this. Oh, Dr. Cario catching me in the hall, like, what's with the beer helmet, Littman? It's like, look, it's coffee. Okay, carry on. Get a face shield that has like fish in it swimming around. Well, did I tell you last class that you can go online and you can buy a weighted thing for a Tesla steering wheel? Oh, this should be illegal. Listen to this. So when you have autopilot on a Tesla, you have to apply a little weight to the steering wheel so they know you're paying attention, right? Well, that can get uncomfortable for long drives. So you can, if you go on Amazon, you can buy a weight that fits the steering wheel perfectly, that has just enough weight for it to be convinced that it's a hand, like an arm. But you know, that sounds like it'd be illegal, right? Okay. So they don't sell it as that. They sell it as a phone holder that attaches to your steering wheel, and they happen to mention that it weighs 2 pounds. Like, oh, I care about how much my phone holder weighs. Okay. But Mr. Gonzalez and I, we found these 2-pound wrist weights on Amazon. But now we're going to 3D print something and then fill it with, I don't know, something that's heavy, maybe even water. It's got to have a use for something, right? Is it minerals, right? It makes it heavier, probably. Yeah. All right, let me switch this back to private. Go ahead.
Hey, there you go. You 3D print a water bottle.
Just 3D print a water bottle? Can't you just go get water bottles like all over the place?
Yeah, but if you can 3D print it, why not buy it?
Well, because a water bottle is more convenient and probably going to be a better final product, because I mean they're effectively I'm sure created in a mold. All right, so that's fixed. Go back into this guy. All right, so we're good with this. Test it one more time, make sure I didn't just bust something, and then I'll push it. All right, looks perfect. What am I pushing? Do I push the entire? Oh, what's this?
I got a call from the IRS.
Oh, I'm sure you your social security number is you have outstanding balance, and they want, or was it really the IRS?
I can't tell. It's definitely not important.
Oh, well, because that's one of like the common scams.
Well, it's just saying that like there's some kind of lawsuit that I like.
Yeah, that's a scam.
Yeah.
Well, yeah, you know, I usually ask them for their home phone number, ask them if I can call them back later tonight. And then they hang up. Or you ask their opinion on some cooking recipe. Like, do you have a suggestion for a good replacement for like ricotta cheese and a lasagna? You know, see what they come back with.
Surprisingly, I've never gotten a home broken scammer on the iOS, so it's very good.
Well, you've had some kind of scam call before.
Yeah, I had warranty scammers. Like your car is your car's warranty is going to expire.
Oh my God, everything got 7 warranties in like 2 days. It was awesome.
All right. So let's talk about stacks. So a stack, did I introduce stacks at all yet?
I think you just said they're like simple.
Okay. I just said it out loud.
Yeah.
You better read it out.
Stack data structure. So this guy is a last in, first out queue.
Like a stack of newspapers.
Yep. So like a stack of magazines
And then a queue is a first.
or a deck of cards, something like that. Whereas a queue data structure, as you said, is a first in, first out fire. This is like a line at McDonald's.
I have a quick question about input skill path.
Mhm.
Is there like any real reason to, in the one that we wrote at least, is there any real reason to have something that points to tail?
To have something that points to tail.
Because like I get why you need something pointing to head just because that's where it starts, and I would get why you would need something pointing to tail so people don't walk backwards to go in.
What if you want to get the last element?
You walk through the whole thing.
Isn't tail then the most convenient way of get end?
Okay, I just wasn't sure if that.
Yeah, or get last. You could have a function called like get last. All right. But I'm going to actually move this Q1 after we talk about stack. So queues we'll actually just introduce. We won't really write anything with it because stacks will give us enough exercise with doing this stuff. So this is a specialized use of a linked list, a simplified use of a linked list, because when we wrote our linked list, the easiest function to write was add front and remove front, right? Well, that's all stacks have to do. So stacks, yep. So we have push and pop. Push adds to the front. Pop removes from the front. All right. Peek just shows you what is at the front. So it's like get at index 0, something like that. Now, really, in terms of like the formal abstract data types, the only required functions for a stack are push and pop. These other ones are kind of convenient functions, specifically peek. Peek is really the third one that might be commonly helpful, where you can say, look, before I do anything with the top of the stack, I just want to see what's at the top of the stack. That's handy for peek. Go ahead.
So since these take in a stack as a parameter, are these not like functions with methods of a stack?
Who? Oh, I see what you're, now that's just this example, like push onto this stack of 44. We're going to be writing it like we did with linked lists. That's just this example. All right. So let's go ahead and we're going to write a stack data structure. Now, we can actually implement a stack in terms of a linked list, right? So I can go over here and I'm going to create my steal this guy. So we'll create a new file, stack HPP. This is going to be a class called stack. But this guy is going to be, is it double prep? There's a single one of those. There we go. So this is equivalent of Java's extends keyword. So a stack is actually going to be a linked list. All right. So that means we don't need to, well, a lot of times we will have a something that points to the top. Actually, we won't need that since we're not implementing this ourselves. So we won't need this. So we don't actually have, in this particular case, any private members. We will have our stack constructor. Then we'll have a push int value, and we'll have a int pop and an int peak. Push pop peak. So pop removes and returns the front of the list. Peak just returns the front of the list, but doesn't actually remove it. Okay. Then we'll go and I'm going to create another file for stack.cpp. And this guy will include stack HPP. We'll probably have some other jazz in there as well. Here's the things that we're going to be implementing. All right. Oh, actually, for a stack, we do need a private section because a stack is built around a linked list, right? So we are going to need the linked list that serves as the basis for our stack. Let's go back into stack HPP. We'll say private linked list pointer LL. Something like that. So go back to stack CPP. So inside here, we're going to go ahead and create our linked list. So we'll say this LL is equal to a new linked list. That'll give us our empty linked list. Okay, push is going to do what? This will be this LL add front value. Pop will be this LL remove front, which returns an int. So we'll go ahead and return that guy. And then peak is just get at index 0. But we don't have access to head in here because it's private. If we made head inside of our linked list, if we made it protected, we'd have access to it. But that's okay because we have a get at index. So we can just say, hey, give me bucket 0. It doesn't remove it, just gets you that value, and you're off to the races. So we can return this LL get at index 0. Is this returning a node? Get payload. What? Oh, it's inaccessible. Did we make that? Oh, we must have made that private. Why did we do that?
If you don't know, then take it public.
I think it's like the card consider like the
Yeah, there we go. Now we have a use for the protected section, because the presumption is here that we might have things that are implemented in terms of linked list. Therefore, we might want to expose get node at index to those guys, but not necessarily make it publicly available. All right. So good use for making something protected, which really maybe last semester we didn't have good examples of that. So I think this is a good example of this. So obviously I did it on purpose. All right, what am I doing? Oh, what time? Oh, class over 11:20, right? Today's Thursday. Go ahead. HPP? That one. Did I screw something up? No, because if I did, it's on purpose. Just like all things. Do you ever dream in code? It never goes away. Doesn't go away. Yeah, where you actually, hopefully most of you are at this point now, but when you're first starting writing software, computer programming is typically pretty hard. Most students prefer to write papers rather than write code. But when you start deciding that, well, as long as the paper's not like crazy long, you know, but once you get to the point where like coding is fun, like, just write the program. My syntax is way better than my English. Nope. Shouldn't be wrong. Did I not save this? I didn't save this. No, it's true. Protected's a thing, isn't it?
If it wasn't the thing, would you not get away with it?
Well, this is Visual Studio Code that's telling me what it's guessing things are. Get node at index. Let me make sure I'm doing the inheritance thing correctly here. C++ inheritance.
If it's protected as a thing.
Yeah, it looks like it's just the colon. Okay. What was that last thing? Oh, this is actually an interesting thing in C++. We won't look at examples of this, but technically C++ supports something called multiple inheritance, where you can have one class that inherits from multiple other classes, which can then create like conflicts. What if both classes have the same other method? You know, like they both have a two-string method or something like that. Then inheriting from two different classes, now you have this like, well, which two-string method did I actually get? Bad idea. And they took it away in C++, or in Java rather. All right, let's see. You know what I want to do here. Protected function declared on line 11. It's not accessible through linked list pointer. Or why not? In a stack, which is a child of that guy. So here, just for a sanity check real quick. Let's just throw this under public and just make sure that fixes it. Yeah, that does fix it. So then the question is why can't I have it in the protected section? Protected should allow it to be, so maybe it's something with no. We know how to fix it, but I want to be able to tell you how protected works, and I want to make sure that, I mean, this should work, so obviously I'm doing something weird. Not accessible through a linked list pointer or object. So I'm inside stack, I have a linked list. Okay, I get what it wants me to do. We're going to dump this. We're going to say a linked list is a stack. All right, so a linked list is a stack. So now inside my constructor for stack, I'm going to say this is equal to a, I need to have the baseline. So when somebody creates this, we're going to ultimately call our parents constructor. So we're going to go ahead and say super. Well, we already included stack. Shouldn't be this dot super. You know how you talk about your parent? Give me a moment. C++ call parent constructor. That doesn't show me. Oh, does it call it directly? Okay, so then it must call the parents class directly. That means the constructor for this guy actually would be up here. I don't even know why I was doing it in that. I think super exists. Doesn't exist? That sounds made up. All right, well, let's see what it does. So with this in mind, I actually don't need a constructor then for my stack since it is a linked list. So then push will say this add front value. And I can say this add front because this guy is, this is a pointer to a stack, which is a linked list. Same thing here. this remove front. Same thing here. This get node at index, get payload. So it didn't like us doing it by way of a linked list. This is the more object-oriented, correct way of doing it. I don't like the fact, this seems very non-C like, to not actually require a constructor for a stack. All right, let's test it, see what breaks. So we'll go ahead and include stack HPP. And then we'll say a stack pointer S is equal to a new stack S dot push 2 3 and technically, since a stack is a linked list, we should have access to display. This is inaccessible. What? Linked list HPP display is a public function, but I can only access it through my children of it. You know what? I think this will let me do it. Yeah, there we go. So, well, let me run it real quick and then make sure it works, then I'll describe what I just did. All right, so there's my stack with I first pushed a 2, then I pushed a 3 on top of that. So one of the things that we saw in the previous, so it seems like here in our link list, this private, protected, public stuff, when something is protected, it is exposed to the child of the class, in this case, a stack, but only inside of the stack implementation. If you are outside the stack implementation, you would say that, oh, well, then, like for instance, if we're out here in driver and I want to access, in this case, this display method. Well, we see that this display method inside of our linked list is actually a public method. So we'd say, well, shouldn't we have access to public methods from our stack? No, only if we extended linked list as a public parent. That then makes the additional, the rest of the abilities of my linked list available through my stack data type. If we go back to our slides here, and we look at this and we say that, let's see, what was that? This guy, well, I really should only have a push, pop, peak, is empty, get length, something like that. So really I could say, well, I'm gonna write all these guys myself and not actually have a way of displaying the stack itself. Does that make sense? Now, because we'd like to display the stack, but because we really say, you know what, a stack really shouldn't allow you to add an index. That's not a stack feature. So if that's the case, what we would, probably the correct way of doing this would be to extend linked list, but not publicly. If I want to write a display method here, I can. And what I would do is I would just call this guy's, I should be able to do that, right? Display.
So you don't have stack
Oh, thank you. Right. So I'm writing my own display method for stack, which just calls the linked list display method. We're just passing the buck. But what we were not doing is we're not exposing all those extra functions from linked list to whoever is using our stack. If we want to do is empty, we want to just fully implement those things. We can say, there's a rule is empty. And this will return this count, return true if this count is equal to 0. That means it's empty. Count is a private member, though, of our linked list. So if we want that to be directly accessible, actually, do I have a get count? Nope. So if I want to make count accessible by stack, so linked lists count accessible by stack, what would I have to do? So here's linked list HPP. If I want to make this variable accessible by inside the stack implementation, what do I need to do? Move it to the protected section.
Include it.
So you put it there in the protected section, which now exposes it to the children of this class. So now he knows about that guy. So is empty will be that. What was the other function? Get length, which returns the count. Yep. So then inside driver here, I should be able to then do S pop and then S display. So it should be 3.2 the first time and then just 2. Uh-oh. What? Did I miswrite pop? Stack. Stack. Just dot remove front in my linked list. True fine. Let me just test peek here real quick. Yeah. Thought we we had this working. What did we break? We have our stack, CPP. We have push, which calls add front. Okay, good there. Gotta push something. Find there. Try display. It's broken. So it's the display function. It doesn't like me calling display from display. What did you do? Oh yeah, it would be. Because I actually want my parents. No. Oh. You're right. So if I call this show, and I make it show in here, if we had the ability to call our parents display, because you're saying we don't have the super keyword, right? So now I should be able to say this dot like that and come out here and say show. And now this guy. There's that. Yeah, so what she was pointing out there, which is start for the day, smart, is when we had this thing as display, this guy was calling his own display method over and 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 over again. All right, so no homework for next class necessarily, but if you wanted to go and look up Towers of Hanoi, we are going to start implementing, so there's like a, find it online here. We're going to start implementing this on Tuesday. So each of our towers is going to be a stack, but instead of it being a stack of integers, it's going to be a stack of disks. All right, something like that. So we'll get a starting point for this on Tuesday and then start writing this stuff. So if you wanted to take a stab at this on your own, try to implement a stack of disk objects where a disk maybe has a length, like this is a disk with a length of 1 versus 2 versus 3, something like that. Because the rules of this say that you can't put something that is larger on a disk that's larger on top of a disk that's smaller. It's against the rules. So if you wanted to get ahead and try to do that on your own, try to create a stack of disk objects. Questions, comments, concerns, bribes? I will save this and I'll push the latest version of the code if you want to go and take a peek. Otherwise, I will see everybody on Tuesday.